Hello students, today I will start new chapter, that is mathematical physics. In this chapter we discuss different principles of mathematics and how these principles are useful in physics and how can we apply them to solve different problems in physics. Here first is quadratic equation. As I think you all have studied this equation in your class 9, but here you have to see that how this equation is useful in physics for different calculations. What is quadratic equation? An algebraic equation in which highest power of variable is 2 is called a quadratic equation. By this you can easily identify any quadratic equation. Any general quadratic equation can be expressed as x square plus bx plus c is equal to 0. Here a, b and c are constants and x is variable. Its solution is given as x is equal to minus b plus minus under root b square minus 4ac upon 2a. If roots of these quadratic equations are alpha and beta, then in that case alpha is equal to minus b plus under root b square minus 4ac upon 2a and beta is equal to minus b minus under root b square minus 4ac upon 2a. Sum of roots is alpha plus beta is equal to minus b upon a and product of roots is alpha into beta is equal to c upon a. Here we will discuss about the nature of the roots. First, when b square minus 4ac is positive and greater than 0, then roots are real and unequal. Next, if b square minus 4ac is 0, then the roots of the equation are real and equal. Third, if b square minus 4ac is negative, then the roots of the equation are imaginary and unequal. Here is a numerical problem. Solve 2x square minus 5x plus 3 is equal to 0. You can solve it easily, but even then I will explain it. To solve this equation, we will compare it by the standard equation x square plus bx plus c is equal to 0. Here a is 2, b is minus 5 and c is 3. We will substitute this in this equation. So x is equal to minus b plus minus under root b square minus 4ac upon 2a is equal to plus 5 plus minus under root minus 5 square minus 4 into 2 into 3 upon 2a. 2 into a is 2. So 2 into 2. Solve this equation. You will get 5 plus minus 1 by 4. Now the two roots are alpha 5 plus 1 by 4 and beta 5 minus 1 by 4. On solving we get alpha is equal to 3 by 2 and beta is equal to 1. On basis of this quadratic equation, solve these two problems by yourself. First is 2x square plus 5x minus 12 is equal to 0. Second is, if the roots of the equation h is equal to ut minus half gt square are t1 and t2, then find t1 plus t2 and t1 into t2. This is the application of quadratic equation in physics. Many more applications you will observe where quadratic equation is of great helpful in solving various problems. Next, I will discuss binomial theorem. Binomial theorem is of great importance at various places in physics. I will discuss this theorem in brief. This theorem says that if n is any integer, positive or negative, or a fraction, and x is any real number, then in that case 1 plus x to the power n is equal to 1 plus nx plus n minus 1 upon factorial 2 into x square plus n minus 1 n minus 2 upon factorial 3 into x cube plus and so on. Here factorial 2 is equal to 2 into 1 is equal to 2. In this way we can calculate the values of different factorials. Similarly, factorial 3 is equal to 3 into 2 into 1 is equal to 6 and factorial n is equal to n minus 1, n minus 2 and so on, 3 into 2 into 1. Here, if the magnitude of this x is very much small than this one, x is much less than 1, then the values of terms x square and higher powers of x are very small and hence can be neglected in this equation. Means this term will be very small, this term will be very small, and all the rest of terms are very small, so they can be neglected in this condition. So we can write this expression like this: 1 plus x to the power n is equal to 1 plus nx. Similarly, we can write 1 minus x to the power n is equal to 1 minus nx, and 1 plus x to the power minus n is equal to 1 minus nx. These are the forms which are basically used here up to intermediate level at various places in physics. So I will discuss few examples. Find the value of 1.003 to the power 4. Generally, if you calculate the value of this term, then what should you do? You should multiply 1.003 4 times and then obtain the value, or you may use logarithms. But you can also solve this equation by using binomial theorem. Like 1.003 to the power 4 is equal to, it can be written as 1 plus 0.003 to the power 4. Now this has become an expression like this. Here you can easily notice that this term in place of x is very much smaller in comparison to 1, and hence we can apply binomial theorem in this form. So we can write 1 plus x to the power n is equal to 1 plus n into x, and we will solve it to get 1.012. This is a simple solution and easy and gives nearly correct value as it comes from other methods. Similarly, we can find the cube root of 215. How can we calculate? Let us see here. Cube root is 215 power 1 by 3. So this can be written as 216 minus 1 power 1 by 3. Here this is 6 to the power 3. This is 1. We can take 6 to the power 3 outside. So here you will get 6. Here you will get 1 minus 1 upon 6 to the power 3. Now we will solve this equation by using binomial theorem, because 1 minus x to the power n. Here x is much smaller than 1. So we can apply this form of binomial theorem. 6 into 1 minus 1 by 3 into 1 by 6 to the power 3 means 1 minus n into x. In place of n, I have written 1 by 3 here. Then again, on simplifying it, we can obtain 5.990741. Now, how will you apply this theorem at different places in physics? I am taking one example. The acceleration due to gravity at height h from Earth's surface is given as g dash is equal to g upon 1 plus h by re whole square. If h is much less than re, then obtain the expression for g dash by using binomial theorem. So what will we do? We will take this expression g dash is equal to g 1 plus h by re whole square. We can write this denominator into numerator, so this power will become minus 2. Now we can see this h is much less than re. This is given in the question. So h is much less than re. Therefore this whole term will be very much small in comparison to 1. So in this case we can apply binomial theorem of this form, and we can write g dash is equal to g 1 plus nx. N is minus 2, so it will become 1 minus 2 into h by re. This is the required solution. There are many other examples which you can find out from your book. Next we discuss some important logarithmic relations. All the general logarithmic relations are written with base small e, while the tables of logarithms are given with base 10. So in physics, generally logarithms are written from base small e, and when we use them in numericals, then we convert base from e to 10. So these relations are of great importance at various places in physics. Log base e m into n, this is log base e m plus log base e n. Now log base e m upon n, log base e m minus log base e n. Next is log m base e is equal to 2.3026 log m base 10. Here you can easily notice that log base e can be converted to log base 10 by multiplying it with a number 2.3026. Next is log m to the power n base e is equal to n log m base e. Log x base x is always equal to 1. Next, here are few basic relations of trigonometry. These relations are frequently used in physics. I know that you are familiar to these relations, but you should note it down on your copies for convenience in future. In our next lecture, we will discuss the most important topic in mathematical physics, and this topic is differentiation and integration.